Welcome to these gentle, soothing stories for sleep. I am so glad that you are here. Whether you are preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion in the stillness of the night, you have come to the right place. Tonight, we will embark on a journey of the imagination, a profound and gentle exploration of a question that touches the very heart of our world's stability. We will ask, if all the ice on Earth melted, not slowly over centuries, but all at once, in a single, silent moment, how would our world cope? Before we begin, I would love to know where you are listening from tonight. Please leave a comment below to share a little of your world with me. Wherever you are, I hope you are feeling comfortable, relaxed, and ready to explore something extraordinary. And if you find these soothing scientific journeys comforting, please consider liking this video and subscribing to the channel. It helps more souls who are searching for peace to find their way here. Imagine, if you will, the quietest sound on Earth. It is not the silence of a deep cave, nor the stillness of a desert at midnight. It is a sound trapped for 1,000,000 years, a whisper from a forgotten atmosphere. It is the sound of ancient air, caught in tiny, crystalline cages of ice within the great polar sheets of Greenland and Antarctica. For millennia upon millennia, these bubbles of air have waited, each a perfect, tiny museum of a world that no longer exists. Now, imagine all of those whispers being released in a single, collective sigh. This is where our story begins, not with a roar, but with a sound so vast and so sudden that it becomes a new kind of silence. In one theoretical, impossible moment, every glacier, every ice cap, every mountain fastness of frozen water, from the highest Himalayan peak to the deepest Antarctic valley, loses its solidity. There is no slow drip, no groaning crack of a calving iceberg. There is only a phase change, a planetary scale transformation from solid to liquid. The air above the poles instantly chills, a profound cold that rushes outwards, carrying with it the scent of ancient, clean air and the faint, mineral smell of scoured rock that has not touched the open atmosphere for eons. The world does not hear a splash, but rather an impossible, all-encompassing crackle, the sound of 1,000,000,000,000,000 crystal bonds dissolving in unison, followed by the deep, resonant hum of water finding its level. Across the whole of Antarctica, a continent larger than the United States and Mexico combined, the 3-kilometer thick shield of ice becomes a vast, clear, and impossibly cold freshwater sea, shimmering under the pale polar sun. The same transformation occurs in Greenland, its icy heart now a colossal inland ocean, spilling its new wealth of water from all sides through the deep fjords that once channeled solid rivers of ice. This is the first moment of our new Earth. This instantaneous transformation, this planetary alchemy, defies the normal laws of energy and time, but to understand its consequences, we must first appreciate the sheer force it represents. In the quiet physics of our everyday world, changing ice to water requires a tremendous amount of hidden energy, a concept scientists call the latent heat of fusion. Think of a simple kettle on your stove. You can heat the water to 99 degrees Celsius, but it remains liquid. To make that final leap to 100 degrees and turn it into steam, you must add a great deal more energy, which seems to vanish into the water without raising the temperature at all, its sole purpose being to break the bonds holding the water molecules together. The same principle applies to melting ice. To change ice at 0 degrees Celsius into water at 0 degrees Celsius, an enormous quantity of energy is required just to unlock the crystalline structure. For our planet to perform this act instantly, it would have to pay a cosmic energy debt of staggering proportions, a release of force so great it would make all of our human endeavors seem like the work of ants. But beyond the physics of heat, the substance that has been released is more than just water. It is a library of deep time. The great ice sheets are built from layers of compressed snow, with each layer trapping bubbles of the atmosphere from its year. To drill a core into this ice is to drill backwards through time, to breathe the air that blew across the Earth during the last ice age, to analyze the volcanic ash of a forgotten eruption, to read the planet's own autobiography, written in frozen water. And in our single moment, this entire library, This entire chronicle of millennia has been liquefied. The stories, the secrets, the very breath of a younger Earth, all released and mixed into the churning, newborn seas. The volume of water is almost beyond comprehension. Over 24 million cubic kilometers. It is a number so large it loses meaning, so let us try to picture it. Imagine the entire continent of Australia, covered in water almost 3 kilometers deep. Imagine all the rivers of the world, the Amazon, the Nile, the Mississippi, the Yangtze flowing together for more than 500 years, and all of that water being held back by a dam which has just vanished. And so, we are left with this image of a planet that has fundamentally changed its state of being. The release of this water is an act of geological exhalation, a million-year-old breath held in the lungs of the ice, now finally released. This breath carries with it the cold of ages, the dust of ancient skies, and the sheer, raw potential of liquid water, the most powerful shaping force on the surface of any world. The chaos of the melt itself, that impossible instant, is already over. It has been replaced by a profound and dreadful quiet, the quiet of purpose. For this colossal new body of water, this global ocean of meltwater, does not simply sit still. It feels the pull of the Earth's core, the ancient and irresistible summons of gravity. And so, it begins to move. Slowly at first, then with gathering momentum, it flows downwards and outwards. A silent, blue tide, beginning a journey that will reshape every coastline, redraw every map, and define the future of our world. Picture the map of the world that you have always known, the familiar shapes of the continents etched into your mind since childhood. Now, in your mind's eye, watch as a soft blue watercolor paint begins to bleed inwards from every coast, not with a painter's speed, but with the slow, inexorable patience of time itself. This is the second act of our story. The rising of the sea. The water released from the melted ice sheets does not arrive on the shores of the world as a crashing tsunami, a single, violent wave of destruction. Its arrival is far quieter and far more permanent. It is a tide that never recedes. It is the slow, deliberate filling of the world's basins. In the first hours, it would be almost unnoticeable, a gentle lapping at the high tide mark that simply does not retreat. But then, hour by hour, day by day, it continues. The world's beaches are the first to vanish, the golden sands of the Mediterranean and the white shores of the Caribbean sinking beneath the placid blue. Then, the water claims the promenades, the piers, the coastal roads. It creeps into the mouths of rivers, turning them from flowing arteries into salty, stagnant estuaries that swell and push deeper inland. London watches as the Thames becomes a vast, sullen lake, its famous bridges slowly submerged until only their highest arches remain. Monuments to a drowned city, the intricate canals of Amsterdam and Venice, once masters of the water, are now utterly consumed by it, their identity erased. Miami and the whole of southern Florida disappear in a dreamlike silence, the skyscrapers becoming lonely, artificial reefs in a warm, shallow sea that stretches for hundreds of miles. The science behind this redrawing of the world is one of terrible and beautiful simplicity. When scientists calculate the potential rise in sea level, they are performing a straightforward, albeit staggering, piece of arithmetic. They take the total volume of water locked away in the land-based ice, those 24 million cubic kilometers, and they spread it evenly across the entire surface area of the Earth's oceans, which covers about 361 million square kilometers. The result of this planetary calculation is a final rise of approximately 66 meters, or about 216 feet. It is the same principle as pouring a large jug of water into a shallow baking dish. The water level must rise. It is important here to understand a gentle but crucial distinction in the world's ice. There are two kinds: the ice that rests upon land, like the colossal sheets of Antarctica and Greenland, and the ice that already floats in the ocean, like the sea ice of the Arctic Ocean. The melting of the floating Arctic sea ice, while devastating for the climate and local ecosystems, would not, in itself, raise global sea levels. This is due to Archimedes' famous principle of displacement. Think of a glass of water with several ice cubes floating in it. The ice is already displacing a volume of water equal to its own weight. When the ice cubes melt, the water they become simply fills the space they were already occupying, and the water level in the glass does not change. But the ice on Antarctica and Greenland is different. It is not in the glass yet. It is sitting on the table beside it. When this ice melts and its water flows into the ocean, it is new water being added to the glass, and the level rises, relentlessly. This addition of 66 vertical meters of water to the world's oceans creates a geography that would be utterly alien to us. The coastlines we know are not just submerged, they are obliterated. In North America, the Atlantic seaboard is gone, and the Gulf of Mexico pushes deep into the continent, turning the Mississippi River into a vast saltwater bay. The Central Valley of California, the agricultural heartland of America, becomes a great inland sea, with the coastal mountain ranges forming a chain of long, thin islands. Across the Atlantic, Denmark and the Netherlands are entirely erased from the map. The Baltic Sea joins with the North Sea, swallowing vast tracts of Germany and Poland. The Black Sea and the Caspian Sea swell, merging and creating a new waterway that stretches deep into Asia. The hills of Rome, once miles from the coast, would become beachfront property, their ancient stones looking out over a new Tyrrhenian sea. In Asia, the densely populated low-lying areas of Bangladesh and the Mekong Delta in Vietnam are lost, displacing hundreds of millions of people. The great coastal cities of Shanghai, Mumbai, and Jakarta become silent, underwater kingdoms. Australia, a continent defined by its coastal population, loses a vast, crescent-shaped portion of its eastern flank, where nearly all of its major cities lie. The world map has been violently repainted, and in this transformation, we are forced to reflect on our ideas of home and permanence. We build our cities from stone and steel, believing them to be enduring symbols of our presence. But in the face of this quiet, rising blue, their permanence is revealed to be an illusion. They become monuments not to our strength, but to our fleeting occupation of a world whose true power we had forgotten. For millennia, humanity has told stories of mythical drowned cities, of Atlantis sinking beneath the waves as a punishment from the gods. In this new world, we have not created one Atlantis. We have created thousands. They are now the silent, submerged museums of our civilization, their streets and squares and homes waiting in the cold, dark water for a future that will never come. But the effect of this newly liberated water is not confined to the surface. Its sheer mass, its unimaginable weight, has been redistributed from two concentrated points at the poles to a thin layer across 70% of the globe. This colossal shift in weight does not just press down upon the ocean floor. It begins to press down on the very fabric of the planet, causing the world itself to stir in its sleep, preparing to adjust its balance in the cosmos. Have you ever experienced a day that seemed to stretch on forever? A long, quiet afternoon where the sun hangs in the sky, refusing to set, and time itself feels as though it has become thick and slow, like honey. In the world after the great melt, this fleeting, subjective feeling becomes a new and permanent physical reality. For every living thing on the planet, every day, from this moment onwards, is just a little bit longer than the one before. The change is imperceptible at first, a subtle dragging at the heels of time, but the rhythm is undeniably different. Sunrises paint the sky a fraction of a second later each morning, and the evening twilight lingers, holding on to the memory of the light for a few heartbeats more. The great, familiar cadence of our planet, the 24-hour waltz that has governed the cycles of life for hundreds of millions of years, has been disturbed. The Earth's very pulse has slowed, and this gentle, disorienting shift is the consequence of that immense redistribution of water we witnessed, a change that has altered the planet's magnificent pirouette in the emptiness of space. To understand this slowing, we can turn to the beautifully simple analogy of a figure skater performing a spin on the ice. When she wants to spin faster, she pulls her arms in tightly towards her body, concentrating all her mass close to her central axis of rotation. The spin becomes a dizzying blur. But when she wishes to slow down, she extends her arms outwards. As her mass moves away from the center, her rotation immediately and gracefully slows. This is a fundamental law of the universe called the conservation of angular momentum, and it applies to everything that spins, from a child's toy top to a whirling galaxy. Before the Great Melt, a vast portion of Earth's water was locked up as ice, concentrated at the North and South poles, very near the planet's axis of rotation, like the skater's arms held tightly to her chest. But in our single, catastrophic moment, that mass was released. The water flowed away from the poles and spread out across the globe, with the largest portion accumulating in a slight bulge around the equator due to the planet's spin. This act is identical to the skater extending her arms. By moving trillions of tons of mass from the axis to the periphery, we have forced the Earth's rotation to slow down. The length of a day would increase by only a few milliseconds, a duration so short you could not perceive it with a stopwatch. Yet, a change to a planet's fundamental constants is never trivial. Our entire technological civilization, for instance, depends on the precise and predictable length of a day. The Global Positioning System, or GPS, that guides our ships and cars relies on a network of satellites whose orbits and clocks are synchronized to a day of a very specific length. This new, slower Earth would introduce cascading errors, making navigation a constant struggle of correction and recalculation. And the effect runs deeper still, into the very heart of biology. Life has evolved with an internal clock, a circadian rhythm tied to the 24-hour cycle of light and dark. This new, longer day would be a constant, low-level source of physiological stress for every plant and animal, a subtle jet lag from which there is no recovery. But the planet does not just spin slower, it also becomes less stable. The shift of mass is so significant that the Earth's very axis of rotation begins to wander. We are not speaking here of the familiar wandering of the magnetic poles, but of the true physical axis around which the planet revolves the geographical north and south poles. Imagine a perfectly balanced spinning top. If you were to gently place a tiny drop of glue on one side, it would begin to wobble as it spins, trying to find a new, stable axis around which to rotate. The Earth, in this new era, is doing the same. The loss of the immense weight of ice at the poles and the gain of water weight around the equator has unbalanced the gyroscope of our world. The North Pole would begin to drift, its true position shifting by perhaps several meters, an effect scientists call true polar wander. This unsteady wobble, combined with the slower rotation, changes the very character of our planet's motion. It is a world that feels a little less certain on its feet, a little more fragile in its cosmic dance. We build our lives upon foundations we believe to be absolute and eternal. The hardness of the rock beneath our feet, the certainty of the sunrise, the unchanging length of a day. These are the metronomes of our existence, the steady beats to which we set our calendars, our stories, and our lives. But this new, unsteady pulse of a slower Earth teaches us a profound lesson. It shows us that even these great cosmic constants are not constants at all, but are instead the results of a delicate and temporary balance. Our planet is not a static stage, but a dynamic and ever-changing partner in the dance, and its rhythm can and will change. And as the planet completes this grand, external adjustment to its spin, a much slower and more powerful internal adjustment is just beginning. The very crust of the Earth, in the places where the ice once lay, begins to stir, preparing to breathe a sigh of relief that will take millennia to complete. Imagine for a moment that you are pressing your thumb firmly into a soft piece of memory foam. You can feel the material yield beneath the pressure, a deep indentation forming. Now, let go. You can watch as the foam slowly, silently, remembers its original shape, rising back up until the mark of your thumb is gone. Now, imagine that the foam is not foam, but a continental landmass of solid rock, and that your thumb was not your thumb, but a shield of ice 3 kilometers thick, pressing down for 100,000 years with a weight that defies imagination. In the moment of the great melt, that weight is instantly removed, and the land, like the foam, begins to rise. This is the beginning of the age of the groaning Earth. From the newly born, ice-free shores of Antarctica and Greenland, a deep, resonant tremor begins, a vibration that is felt not just along the familiar fault lines, but across the entire planet. It is the sound of rock stretching, of continents unburdening themselves. The ground is no longer a symbol of stability. It has become a living, shifting, and profoundly unsettled thing. This is not a sudden, violent uplift, but an unstoppable, deep exhalation of stone. The land that was once the floor of a great glacier, a realm of crushing pressure and absolute darkness, now begins its long journey back towards the sun, rising from the cold sea that surrounds it. This majestic and terrifying phenomenon is known to geologists as isostatic rebound. The principle is elegantly simple and is based on the idea that the Earth's crust, the lithosphere, is not a single solid shell, but is broken into plates that float upon a deeper, hotter, and much more fluid layer of the mantle, called the asthenosphere. You can think of a continent as being like a great wooden cargo ship floating in the water. When the ship is heavily laden with containers, it sits low in the water. But as you begin to unload the cargo, the ship rises, floating higher and higher. The great ice sheets were the cargo, and the continents were the ships. For millennia, their immense weight pressed the land masses of Greenland and Antarctica down, causing them to sink deeper into the soft mantle below. Now that the ice cargo has been instantly unloaded, these continents begin to float upwards, seeking a new, lighter equilibrium. We can see this process happening in our own world today, in places like Scandinavia and Hudson Bay in Canada, which are still slowly rising after the last ice age ended over 10,000 years ago. But our scenario is different. The rebound is not a gentle process playing out over centuries. The sudden release of pressure sends a shockwave through the entire planetary crust, inducing a new and terrifying era of geological instability. The consequences of this rapid adjustment are felt everywhere. The change in stress across the Earth's tectonic plates awakens sleeping giants. It is like a complex web of interconnected strings, all held in a delicate tension. The sudden release of tension at the poles causes the entire web to shudder. Fault lines that have been dormant for thousands of years are suddenly squeezed or stretched, pushing them past their breaking point. The Pacific Ring of Fire, that great circle of volcanoes and earthquake zones that rims the Pacific Ocean, would erupt into a period of unimaginable activity. Volcanoes from the Andes to Indonesia would spew ash into the perpetually grey sky, and devastating earthquakes would shake the newly formed coastlines of the world, triggering colossal underwater landslides that send true, destructive tsunamis racing across the shallow new oceans. This induced seismicity means that nowhere is truly safe. The planet's crust is groaning and cracking, trying to settle into a new configuration. And all the while, the new lands themselves continue their ascent. The landscapes that emerge from the sea are alien and stark. They are not green and fertile, ready for life. They have been scoured and sterilized by the moving ice, scraped down to the bare bedrock. They are vast plains of crushed rock, gravel, and boulders, carved with the deep scars of glacial valleys, a raw, new world that has not felt the warmth of the sun or the touch of rain for a geological age. In witnessing this, we are reminded that the Earth is not merely a passive backdrop for the drama of life, but an active, breathing entity with a deep memory written in its very stones. The rising of the land is like a shoulder, finally shrugging off a burden it has carried for longer than our species has existed. It is a planetary-scale act of remembering a time before the cold, a deep, physical yearning for an older, unburdened shape. The constant tremors are the planet's unsettling dreams, the seismic echoes of the weight it once carried. We think of the ground as solid, as the ultimate definition of permanence, but it is a fluid, dynamic system, constantly in motion on a timescale too slow for our fleeting lives to notice. But in this new world, that timescale has been shattered, and we are forced to witness the slow, powerful breathing of the land itself. And while this new, bare rock is rising into the sky, the water that now covers so much of the world, this vast ocean born of fresh, not salty, ice, is about to undergo its own silent crisis. A change in its fundamental chemistry is about to still its heart, triggering a climatic shift that will be felt from the equator to the newly liberated poles. Imagine a river. But this river is not like any you have ever seen. It does not flow between banks of earth, but between walls of colder, denser water. It is a river wider than any continent and deeper than the tallest mountain, flowing in the silent, sunless dark, thousands of feet beneath the waves. Its current is 1,000 times greater than that of the Amazon, a slow, majestic, and invisible force that carries the warmth of the tropics towards the frozen poles, acting as the great circulatory system for the entire planet. This is the ocean's great conveyor belt, a current whose real name is the Atlantic Meridional Overturning Circulation, and its steady, reliable pulse has governed our climate for millennia. Now, imagine it stopping. In the world after the Great Melt, this is precisely what happens. The effect is not immediate, but it is catastrophic, and it unfolds with a chilling, paradoxical logic. In a world that has just absorbed a tremendous amount of energy to melt its ice, great swathes of the northern hemisphere begin to plunge into a deep and bitter freeze. The mild, damp winters of Great Britain become Siberian, with heavy snows burying the drowned city of London under a new kind of white blanket. The vineyards of France and Spain, which for centuries have enjoyed a gentle climate, are scorched by a brutal, relentless frost. The life-giving monsoon rains of South Asia, which depend on the subtle temperature differences in the Indian Ocean, fail to arrive, bringing unprecedented drought to billions of people. The familiar, predictable patterns of the weather are not just disturbed, they are broken, because the silent, beating heart of the ocean has stilled. To understand this planetary heart failure, we must journey to the cold, northern reaches of the Atlantic Ocean, between Greenland and Scandinavia. For thousands of years, this has been the engine room of the world's climate. Here, warm water, flowing north from the tropics in currents like the Gulf Stream, releases its heat into the atmosphere, giving Western Europe its famously temperate climate. As this water cools, it also becomes saltier, because the process of evaporation leaves the salt behind. This combination of being both very cold and very salty makes the water incredibly dense. And so, in this one crucial region of the world, the surface water becomes heavier than the water beneath it, and it begins to sink. It plunges downwards, 2.5 miles into the abyss, a colossal slow-motion waterfall in the heart of the ocean. This sinking is the driving force of the entire system. It pulls more warm water northwards to replace it, like a plug being pulled in a global bathtub. This is the Great Conveyor, a beautiful system of thermohaline circulation, a name which simply means it is driven by thermo, for temperature, and haline, for salt. But the Great Melt has delivered this system a fatal blow. The trillions of tons of water that poured from the melted ice sheet of Greenland were not only cold, they were also almost entirely fresh. This colossal influx of fresh water now spreads out across the surface of the North Atlantic, creating a vast, buoyant lid. This lid of cold, fresh water is simply not dense enough to sink, no matter how cold it gets. It floats on top of the saltier, heavier water below, effectively smothering the engine of the entire global circulation. The great sinking, the planetary heartbeat, stops. With the conveyor belt switched off, the entire system of global heat distribution breaks down. It is as if the radiator system for a vast house has been turned off. The rooms closest to the furnace, the tropics, and the equator no longer have a way to export their excess heat, and so they become oppressively, dangerously hot. Meanwhile, the rooms far from the furnace, the temperate latitudes of North America and Europe, no longer receive their shipments of warmth, and they chill dramatically. The temperature differential between the poles and the equator, which drives all of our weather systems, becomes extreme and unstable. The world is thrown into a state of climatic chaos, a violent pendulum swinging between extremes of heat and cold, drought and flood. The gentle, predictable world we knew was a gift, a brief period of stability delivered to us by this silent, invisible river in the sea. We never saw it, we never felt it directly, but our farms, our cities, and our very lives depended on its faithful, rhythmic flow. And in its absence, we are forced to reflect on the intricate and invisible connections that weave our world into a single, functioning whole. We learn that an event in the cold, sunless depths, thousands of miles away, can determine the fate of a wheat field in the sunlit plains of Europe, or the arrival of a cloud over the parched fields of India. The world is not a collection of separate places, but a single, exquisitely complex machine, and we have just witnessed one of its most critical gears grind to a halt. This silent change in the deep ocean, this stilling of the great river, now sends a profound and very visible signal to the sky above. The new surface of the sea and the new chaos in the atmosphere is about to change the very nature of our air, our clouds, and our light. Can you remember the feeling of a crisp, clear, blue sky? Can you recall the sensation of tilting your head back and feeling the sheer, uninterrupted infinity of the deep blue above, the brilliant, sharp-edged light of a midday sun, or the diamond dust scatter of the stars in a cold, clear night? In the world after the great melt, this memory becomes a priceless treasure, a story told to children who cannot possibly comprehend it. Because in this new world, the sky is gone. It has been replaced by a permanent, near-universal ceiling of thick, low-lying cloud and fog, a white blanket that smothers the continents and oceans alike. The world now exists in a state of perpetual twilight. The sun is no longer a distinct orb in the sky, but a diffuse, pearly white glow behind a featureless grey screen, a source of light without a clear location. Shadows are soft and indistinct, and colours are muted, as if the world were a photograph that has been left to fade in the sun. The horizon, that fundamental line that has always given us our sense of distance and perspective, has vanished, dissolved into a uniform grey haze where the sea blends into the sky. The air is thick with moisture, and sounds are dampened, muffled by the heavy, wet atmosphere. The sharp crack of a breaking twig, or the clear call of a bird, is absorbed by the fog, creating a world of whispers and muted echoes. It is a profoundly claustrophobic existence, a life lived indoors, even when you are outside. This planetary shroud is the direct and inevitable consequence of the new ocean below it. With the Earth's surface now covered by a significantly larger area of water, and with the equatorial regions becoming intolerably hot due to the failure of the ocean currents, the rate of evaporation into the atmosphere becomes immense. The air becomes saturated with water vapor, thick with a humidity you can feel on your skin, like the air in a tropical greenhouse. But everywhere, all the time. This abundance of moisture is the first ingredient for perpetual cloud cover. The second ingredient is the chaotic temperature difference that now exists across the globe. Clouds form when warm, moist air rises, cools, and the water vapor within it condenses into tiny liquid droplets or ice crystals. In this new world, the atmosphere is in a constant state of turmoil, with superheated air from the tropics violently colliding with the frigid air flowing down from the chilled northern latitudes. This creates endless atmospheric instability, constantly forcing the moisture-laden air upwards, where it inevitably condenses into vast, planet-spanning layers of stratiform cloud. Without the stable, high-pressure systems that used to grant us weeks of clear skies, these clouds rarely, if ever, break. The world is trapped beneath a permanent weather front. This global cloud cover does more than just change the view. It fundamentally rewires the planet's energy system through a powerful physical principle known as the albedo effect. Albedo is simply a measure of how reflective a surface is. A dark surface, like the deep blue ocean, has a low albedo. It absorbs most of the sunlight that hits it, converting it to heat. A bright surface, like fresh snow or a white cloud, has a high albedo. It reflects most of the sunlight back into space. In the first moments of the Great Melt, the loss of the planet's bright, reflective ice sheets would have drastically lowered the Earth's overall albedo, causing it to absorb more solar energy and warm up. But now, this new and permanent shield of brilliant white clouds has the opposite effect. And on a much grander scale, this cloud layer acts as a vast, planetary mirror, reflecting a huge portion of the incoming solar radiation back out into the cosmos before it can ever reach and warm the surface. This initiates a powerful global cooling effect, a kind of aquatic winter that wages a constant war with the warming from the greenhouse gases below. The Earth's thermostat is now utterly broken, no longer able to find a stable equilibrium, and is instead locked in a violent struggle between the heating from the ocean and the cooling from the clouds. The planet has lost its gentle balance and has become a place of warring extremes. We are beings who have always looked to the heavens for guidance, for inspiration, for a sense of our place in the universe. Our ancestors navigated by the stars, created calendars from the movements of the sun and moon, and saw the faces of their gods in the shifting shapes of the clouds. What does it do to the human psyche, to the very soul of a species, to be permanently cut off from the cosmos? To live a life where you can never see the sun, never navigate by the North Star, never wonder at the majesty of the Milky Way. It is a kind of sensory and spiritual solitary confinement. And while this grey, featureless blanket often brings a sense of muffling calm, it is a deceptive peace. For when enough energy does manage to build up in the hot, humid air trapped beneath it, the storms that finally break through this ceiling are not the storms we once knew. They are something else entirely. Monsters born of a wounded and chaotic world. We used to name our storms. We gave them familiar, human names, like Andrew, or Katrina, or Maria, as if to tame them, to bring these vast, chaotic forces of nature down to a scale that we could comprehend and chronicle. But what do you call a storm that is the size of a continent? What name do you give to a hurricane whose winds howl for months on end? A single, unrelenting storm that becomes a permanent feature of the New World map. These are not events to be named and tracked. They are the new climate. They are the great heat engines of a wounded planet, striving in vain to achieve the balance that the ocean currents once provided. Beneath the perpetual grey ceiling of the clouds, the world has become a nursery for monsters. The experience of living on a shore, lashed by one of these hyper-hurricanes, would be an existence of constant, soul-crushing noise and pressure. The wind is not a gusting, variable force. It is a solid, unyielding river of air, a relentless presence that leans against the world with unimaginable weight, eroding solid rock and sculpting the landscape into new, wind-blasted forms. The rain is not composed of individual drops, but is a solid, descending curtain of water, a vertical flood that turns the land into a sea of mud and tears, mountainsides down in roaring landslides. The sound is the most overwhelming part, a deafening, bass-heavy roar that never, ever ceases. A noise so constant and so profound that it becomes the new definition of silence. The physics that give birth to these colossal storms is a direct consequence of the planet's new, broken state. A hurricane, in its simplest form, is a heat engine. It is a machine that takes the thermal energy stored in warm ocean water and converts it into the kinetic energy of wind and waves. Its fuel is a sea surface temperature of at least 26.5 degrees Celsius, extending down to a significant depth. In the world after the melt, with the ocean's circulatory system shut down, the equatorial oceans have become a vast, superheated reservoir of energy, far hotter and deeper than the waters that spawned the hurricanes of our time. Simultaneously, the upper atmosphere, chilled by the reflective, high albedo clouds, is colder than ever before. This creates an enormous temperature differential, a steep energetic cliff between the sea and the sky. This extreme gradient makes the planetary heat engine terrifyingly efficient, capable of building and sustaining storms of a power that our own meteorological science would have deemed impossible. But it is the slowing of the Earth's rotation that gives these storms their most defining characteristic: their immense size. The spin of a storm, its iconic spiral shape, is a gift from the planet's own rotation, a phenomenon known as the Coriolis effect. In our old world, this effect was strong enough to organize rising columns of air into tight, compact vortices relatively quickly. But on a slower spinning Earth, the Coriolis effect is weaker. This allows a developing storm system to grow outwards for much longer, drawing in moisture and energy from a truly vast area, before the weak Coriolis force can finally pull it together into a spinning, organized whole. The result is fewer storms, but storms that are an order of magnitude, larger continent-spanning vortices that wander the globe like great, angry gods. The effect of these persistent, rain-drenched behemoths on the new landscapes of the world would be profound. The sheer volume of water they pull from the oceans and deposit on the land would initiate an age of erosion not seen since the primordial days of the Earth. Entire mountain ranges would be softened and worn down in the span of centuries, their substance washed into the sea as thick, muddy plumes. New canyons and river valleys would be carved into the rock in a matter of years, a geological process that should take millennia happening at the speed of a single, unending storm. The new coastlines, already unfamiliar, would be in a constant state of flux, relentlessly battered by a storm surge that is not a temporary event, but a permanent raising of the sea level in the storm's vicinity. In this new world, we are forced to reflect on our relationship with power. We thought we had tamed nature, that we could predict its furies and build walls strong enough to keep them at bay. We named its tempests to give ourselves the illusion of control. But these hyper-hurricanes are a humbling reminder of what planetary power truly is. They are not aberrations from the climate, they are the climate itself. They are the planet's new, violent method for moving heat, a chaotic and destructive substitute for the gentle, silent river that once flowed in the ocean's depths. And as these storms rage, their winds churning the surface of the global ocean into a constant froth, they are also stirring the water, mixing and aerating its surface layers, and bringing the strange, new chemistry of this diluted, overburdened sea to the forefront of the world's story. Imagine taking a single glass of seawater, with its familiar, sharp, briny taste, the essence of the ocean that has existed for millions of years. Now, in your mind, pour it into a larger vessel and dilute it with 3 glasses of cool, clear, fresh water. Swirl it gently. The resulting liquid would look much the same, but its fundamental character would be irrevocably altered. It would be weaker, less vibrant, its ancient saltiness a mere ghost of what it once was. What would this simple act of dilution mean for the trillions of creatures that have evolved over eons to call the original, salty ocean their home? This is the chemical crisis that unfolds in the world's new oceans. It is a change not just of volume and temperature, but of the very substance of the water itself. The sensory experience of this new ocean is one of profound difference. Standing on a newly formed shore, the air in your lungs no longer carries that clean, sharp, salty tang. Instead, it smells of damp earth, of the rich scent of petrichor rising from the perpetually soaked land, and of the slow, sweet decay of countless drowned forests and plains. Looking out at the water, it is not the deep, clear blue of a healthy ocean, but is often clouded, a murky, green or brown, thick with the suspended sediment and organic matter flushed from the continents by the hyper-hurricanes. It is an ocean that feels less like a cradle of life and more like a vast, planetary swamp. The first and most immediate chemical shock is the collapse of salinity. Salinity is the measure of all the dissolved salts in water, and for millennia, it has been one of the most stable parameters of the Earth's oceans. Every creature that lives in the sea is exquisitely adapted to this specific salt concentration. Their very cells are built to maintain a delicate internal balance with the water outside them, a process governed by osmosis. Think of a saltwater fish. Its cells contain a specific concentration of salt. To prevent the less salty water of its own body from leaking out into the hypersaline ocean, it has evolved complex mechanisms to drink seawater and excrete the excess salt. Now, place that same fish in the new, diluted ocean. The water outside its body is now significantly less salty than the fluid inside its cells. In a fatal act of osmotic rebellion, the fresh water of the ocean rushes into the fish's cells, trying to balance the concentration. The cells swell with water and, one by one, they burst. For the vast majority of saltwater species, from the smallest plankton to the great whales, this sudden, catastrophic drop in salinity is a lethal physiological shock from which there is no adaptation and no escape. But the chemical assault does not end there. As the rising waters drowned the continents, they submerged uncountable trillions of tons of organic matter forests, jungles, grasslands, and the entire biomass of Earth's soils. In the warm, shallow waters of the new coastlines, this material begins to decay, a process consumed by bacteria that releases vast quantities of carbon dioxide directly into the water. This dissolved carbon dioxide undergoes a chemical reaction, forming carbonic acid, which is written as H2CO3. This process dramatically lowers the ocean's pH, tipping it towards a more acidic state. This rapid acidification is especially devastating for the organisms that form the very base of the marine food web. Corals, clams, oysters, and countless species of plankton that build their protective shells and skeletons from a mineral called calcium carbonate. In an acidic ocean, this mineral begins to dissolve. For these creatures, it is as if the very bricks of their homes are being stolen away, their skeletons and shells weakening and crumbling, leaving them vulnerable and unable to survive. Finally, deep below the roiling surface, another, more silent crisis is unfolding. The shutdown of the Great Ocean Conveyor Belt means that the normal, life-giving transport of oxygen from the surface to the deep sea has ceased. The abyss is no longer ventilated. As the massive pulse of organic matter from the drowned lands sinks into this stagnant deep, it is consumed by bacteria. This decomposition consumes all the available dissolved oxygen, creating vast, continent-sized regions of the ocean that are completely devoid of oxygen. These are anoxic zones, immense dead zones where nothing that requires oxygen to breathe can live. The deep oceans, once home to a weird and wonderful array of life, become a silent, toxic tomb, inhabited only by ancient forms of anaerobic bacteria. And so we are left to reflect on the nature of life itself. We so often see it in its beautiful, complex forms: a shimmering fish, a vibrant coral reef, a majestic whale. But these are just the dancers. We are often blind to the stage upon which they perform, a stage built of an invisible architecture of precise chemical balances. Life is a delicate chemical dance, and it can only be performed if the salinity is just right, the pH is stable, and the oxygen is plentiful. In the new chemical sea, the stage itself has dissolved, and the dancers, in their billions, are now falling into a final, silent abyss. For these creatures, who for millions of years have danced to the steady rhythm of the old ocean, this new and hostile chemical reality is not simply a challenge to be overcome, it is an executioner, arriving for them all at once. Listen. In the profound quiet that follows the great storms and the chemical altering of the seas, a new, deeper silence begins to settle upon the world. It is not the silence of peace, but the silence of absence. It is what is left when you remove the ceaseless, clicking chatter of a million shrimp on a coral reef. It is the vast, empty quiet of an ocean no longer crossed by the deep, resonant songs of the great whales. It is the stillness in the air where the cries of 1,000 species of seabird used to be. It is the sound of an orchestra that has lost most of its instruments, a hum that has faded to a whisper. It is the sound of extinction, and it is the most patient and most permanent silence of all. Let us take a journey through this new, emptier world. We glide over a great coral reef, a structure that was once the most vibrant and diverse ecosystem on the planet. A bustling metropolis of life. But now it is a ghost city. Its intricate, branching structures are uniform, skeletal white. The coral animals, unable to survive the changes in temperature, salinity, and acidity, have perished, leaving behind only their beautiful empty homes. The million brightly coloured fish that once swarmed these ramparts are gone. The quiet hum of the reef's life has been replaced by the gentle, lonely sound of water moving over dead stone. We travel out into the open ocean, into the sunlit zones where great shoals of tuna and mackerel once turned the water into a boiling, shimmering silver. The water is now clear and empty. We journey into the dark, cold polar regions, where the nutrient-rich waters once supported vast blooms of krill, the foundation of an entire ecosystem. The krill are gone, and so are the seals, the penguins, and the great baleen whales that came here to feast. We see them, perhaps, in these last days, the gentle giants of the sea, confused, starving, calling out into a world that no longer provides for them, their songs fading unanswered into the deep. The mechanisms of this great dying are as brutal as they are simple. The first and most swift executioner is the osmotic shock we have spoken of before. For nearly all marine life, from the simplest single-celled algae to the most complex fish, the sudden dilution of the ocean is a fatal blow. Their cells, which for millions of years have been finely tuned to a specific salt concentration, are invaded by the less salty water, swelling and rupturing in a catastrophic failure of their most basic biological machinery. It is a death that happens at the cellular level, an enemy they cannot see and have no defense against. But for any species that might miraculously survive this first great filter, a second, slower, and even more certain death awaits. Starvation. The entire, intricate food web of the global ocean, that beautiful pyramid of life, is built upon a foundation of microscopic organisms called plankton. There are the phytoplankton, tiny plant-like cells that capture the energy of the sun, and the zooplankton, miniature animals that graze upon them. These creatures are the grass of the sea, the primary producers that sustain all other life, and they are among the most vulnerable to the changes in salinity and acidity. As the plankton vanish, the pyramid of life collapses from the bottom up. The tiny fish and crustaceans that fed on them have nothing to eat. The larger fish that preyed on them in turn begin to starve. The cascade of extinction ripples upwards, link by broken link, until it reaches the apex predators: the sharks, the dolphins, and the whales. An ocean, no matter how vast, is a desert if its microscopic heart stops beating. And this dying is not confined to the water. Life on Earth is a single, interwoven tapestry, and a thread pulled in the ocean is felt on the land. The rising of the seas has drowned every coastal estuary, salt marsh, and mangrove forest on the planet. These ecosystems were the vital nurseries for countless species of fish and invertebrates, and their loss is a final blow to any hope of marine recovery. They were also the critical feeding and resting grounds for billions of migratory birds. Now, these great aerial rivers of life find their journeys interrupted, their destinations gone, and their populations begin a steep and irreversible decline. The world is becoming fundamentally, biologically impoverished. And so, we are left to reflect on the nature of this loss. We often think of extinction as a distant, almost abstract concept, something that happened to dinosaurs in a dramatic, fiery spectacle. But this great dying is not like that. It is a quiet and pervasive subtraction. It is the erasure of a billion tiny, perfect details that, together, made the world whole. It is a color that will never be seen again, a song that will never be sung again, a form of beauty that has been permanently removed from the universe. And in the great, silent spaces left behind by this immense loss, in the empty reefs and the barren seas, a question begins to form. In a world where everything we understood as life is vanishing, is anything left? The answer is yes, for in the deepest, darkest, most toxic corners of this new ocean, a different and far more ancient form of life is not just surviving, it is awakening. We tend to think of life, our kind of life, as the only kind. We are creatures of sunlight and oxygen, and we build our understanding of the biological world around these two vital pillars. We see life as a great, green engine, powered by the sun. But what if there is another kind of life, a form that existed on Earth for 1 billion years before the sky was blue or the air was breathable? What about the life that finds oxygen to be a corrosive poison, and for whom the sun is an irrelevant, distant star? As the new, younger forms of life perish in the great dying, it is these ancient forms that begin to rise and reclaim the planet. Let us descend, far from the light, into one of the vast, anoxic basins that now fill the deep ocean. The water here is still, cold, and utterly black. There are no fish, no crabs, no shrimp. There is nothing that breathes. But the landscape is not dead. The sea floor, covered in a thick ooze of decayed matter from the drowned world above, is painted with shimmering, iridescent bacterial mats, great patches of colour that seem to glow with a faint, internal light. From cracks in the seabed, where superheated, mineral-rich water vents from the planet's interior, we see strange forests of pale, white tube worms, some many feet long, swaying gently in the non-existent current. This is a completely alien ecosystem, a world that runs on a different set of rules, powered by a different kind of energy. It is a scene from our own planet's most distant, primordial past, reborn in the deep. The creatures that thrive in these seemingly hellish conditions are known collectively as extremophiles, a name that simply means lovers of extremes. And the secret to their success, the engine that powers their strange world, is a process called chemosynthesis. It is the dark mirror of the photosynthesis that powers our world. Photosynthesis uses the energy from sunlight to build organic molecules, creating food from light. Chemosynthesis does the same, but it harvests its energy not from light, but from chemical reactions. The bacteria that form the base of this new food web are, in essence, eating rocks and poison gas. They metabolize compounds like hydrogen sulfide, the gas that gives rotten eggs their signature smell, or methane, harnessing the small bursts of energy released when these molecules are broken apart. This is life running on geothermal heat and chemical decay, not solar power. And this new world has just been given an almost unlimited supply of its favorite food. The catastrophic changes in ocean temperature and pressure have destabilized the vast frozen deposits of methane that were locked away in the seafloor sediments of the old world. These deposits, known as methane hydrates or fire ice, begin to thaw and subrelease massive, bubbling plumes of methane gas into the water column. For the oxygen-breathing life of the old world, this would be an irrelevant, even toxic, event. But for the chemosynthetic bacteria known as methanotrophs, methane eaters, it is a feast. They bloom in unimaginable numbers, forming thick, cloudy layers in the water, becoming the new primary producers, the new grass of this dark, deep, and alien sea. This shift represents a profound reversion in the planet's biological history. For the first half of Earth's existence, life was entirely anaerobic. It did not use oxygen. In fact, when the first photosynthetic bacteria began releasing oxygen as a waste product, it triggered one of the planet's first great mass extinctions, as this new, highly reactive gas was toxic to most existing life. The ecosystems now blooming in the deep, anoxic oceans are an echo of that more ancient, pre-oxygen world. They are a return to the planet's microbial roots. The future of life on this transformed Earth is being built upon a foundation borrowed from its most distant past. The rise of these ancients forces us to confront the narrowness of our own definition of life. We are profoundly biased by our own biology. Because we need light and air, we assume that all life must need light and air. We define a habitable world as one that looks much like our own. But the story of the extremophiles is a humbling lesson in nature's creativity and resilience. It is a reminder that life is not a delicate flower, but a stubborn, tenacious force that will take root in any crack that offers the slightest sliver of energy. It flourishes in boiling volcanic vents, in hypersaline pools, in rock miles beneath the ground, and now in the toxic, oxygen-free tomb of a drowned world. And as this new, microbial empire grows, consuming the chemical soup of the new ocean, its activities begin to produce byproducts. The vast quantities of methane being processed and released do not all stay in the deep water. A portion of it, a significant and growing portion, begins its slow, bubbling journey upwards, destined to escape the surface of the sea and enter the atmosphere, where it will begin to fundamentally change the very nature of the air the survivors breathe. Take a deep, slow breath. Feel the air as it enters your nostrils, cool and clean. Feel it fill your lungs, a gentle, life-sustaining expansion. It is the most simple, most fundamental, and most unconscious act of our existence. This constant, rhythmic exchange with the invisible ocean of air in which we live. We trust it implicitly. We trust that each breath will be like the last, that it will nourish and sustain us. Now, what if that trust was broken? What if every breath became a gamble, a conscious act of weighing risk against necessity? This is the reality in the thin, high-altitude air of the New World. The atmosphere, like the oceans and the land, has been fundamentally altered, its chemistry rewritten by the consequences of the Great Melt. It is a thicker, heavier, and more treacherous substance. The air is perpetually damp, so humid that it feels like you are breathing water, a suffocating heaviness that clings to the skin and chills the bone. And it carries new smells. The clean, crisp scents of the old world are gone, replaced by the ever-present, organic odor of a global swamp, a scent of wet earth and slow decay. And near the coasts of the new, strange oceans, another smell often drifts on the wind. The sharp, unpleasant tang of sulfur, the faint scent of rotten eggs that speaks of a poison rising from the anoxic deep. The quality of the light that filters through the permanent cloud deck is also different now, tinged with a sickly yellow-brown hue, as if the sky itself were bruised. This poisoned air is the result of the new life that now dominates the planet. The vast anaerobic ecosystems, thriving in the deep ocean, are consuming the chemical soup of decayed matter and, in the process, are exhaling a new atmosphere into being. The most significant component of this exhalation is methane, a simple molecule with the chemical formula CH4. While the survivors of the old world knew of methane, they understood it primarily as a potent greenhouse gas, and now its effects are unleashed on a planetary scale. While carbon dioxide, or CO2, is often described as a blanket that warms the Earth, methane is a thick, heavy quilt. Molecule for molecule, it traps heat far more effectively. The colossal release of methane from the thawing seafloor hydrates, and the newly drowned permafrost begins to create a powerful runaway greenhouse effect. This intense warming from below wages a constant, violent war with the intense cooling caused by the reflective clouds above, throwing the climate into a state of chaotic, unpredictable flux. But methane is not the only gas rising from the sea. In the vast, oxygen-free zones of the ocean, sulfate-reducing bacteria are also thriving. As they metabolize organic matter, they produce a toxic byproduct, hydrogen sulfide, with the formula H2S. This is the gas responsible for the smell of rot and decay, and in high concentrations, it is a lethal poison. It bubbles up from the stagnant ocean and seeps into the air, particularly in low-lying coastal areas. It tarnishes metal, sickens animals, and makes the simple act of breathing a dangerous proposition. The new climate, then, is a broken system, a world without a stable equilibrium. It is locked in a titanic struggle between opposing forces. The high albedo of the global cloud cover acts like a giant parasol, reflecting sunlight and pushing the planet towards a deep freeze. At the same time, the methane-rich atmosphere acts like a suffocating greenhouse, trapping the heat that does get through and pushing the planet towards a sweltering, humid hothouse state. The result is not a stable balance, but a series of wild, unpredictable oscillations. The world might endure a decade of chilling, bone-damp cold, only to swing violently into a period of oppressive, feverish heat, where the humid air is almost too thick to breathe. The familiar, gentle rhythm of the seasons is gone, replaced by a chaotic and dangerous uncertainty. We are creatures who evolved to live at the bottom of a very specific, very stable ocean of air. We trusted its composition and its predictability, as we trusted the ground beneath our feet and the rising of the sun. We were, in a very real sense, children of our atmosphere. And in this reflection, we understand that the air is not just an empty space, but a delicate, complex, and fragile system, just as vital and just as vulnerable as the oceans of water. Its health is our health, and its corruption is our own. For the few, scattered tribes of human survivors, huddled on the high mountain peaks that have become the world's new islands and coastlines, this new, treacherous atmosphere is a constant, oppressive presence. It is a daily challenge not just to their physical bodies, but to their courage, their hope, and their very sanity. How do you mourn for a whole world? Where do you begin the process of grieving when the thing you have lost is everything you have ever known? Your home, your nation, your history, the graves of your ancestors, the very shape of the land that defined you, all of it gone, resting silently beneath a deep, cold, and endless ocean. This is the fundamental psychological question that haunts the human survivors in the world after the Great Melt. It is a sorrow so vast, a loss so complete, that it transcends personal grief and becomes the defining feature of a new human culture, a civilization built on a foundation of memory and melancholy. Let us imagine one of these surviving communities, a small village clinging to the slopes of what was once the Rocky Mountains, now a dramatic, storm-lashed coast. Their lives are hard, the daily struggle for existence against the harsh new climate and the strange, impoverished ecosystem. But the most significant feature of their lives is not the physical hardship, but the psychological weight of what has been lost. Their culture is saturated with the past. The oldest members of the community, the long memories, are revered, for they can still remember the before time. They speak of a world of vast, dry lands that stretched for thousands of miles, of cities that held more people than are now left on the entire planet, of a sky that was blue. Their stories are the community's most precious heirlooms, told and retold around the fire on long nights, tales of a paradise lost to the great, rising water. The condition that defines these people has a name in our own time, a gentle and profoundly sad word: solastalgia. It is not nostalgia, which is the longing for a home you have left behind. Solastalgia is the distress, the homesickness you feel when you have not left home, but your home has been irrevocably changed and diminished around you. It is the grief for a lost landscape. For the survivors of the Great Melt, solastalgia is not a fleeting emotion. It is the permanent condition of their existence. Every glance out at the vast, grey ocean is a reminder of the world that lies beneath it. Every strange, unfamiliar plant they eat is a reminder of the lost bounty of the old world. They are psychic refugees in their own homes, haunted by the ghost of a planet. This profound trauma becomes a cultural inheritance, passed down through the generations. The first survivors felt the sharp, immediate pain of personal loss. Their children, born into the new world, inherit this pain as a kind of cultural sorrow, a grief for something they have never seen, but whose absence defines their every moment. Their art is not of celebration, but of remembrance, depicting the strange, angular shapes of the drowned cities, as told in the old stories. Their music is elegiac, full of long, sorrowful notes that mimic the sound of the wind over the endless water. Their myths and religions are all centered around this one great, defining event, the flood that never ended. In this new and difficult world, the very definition of what is valuable has been transformed. The abstract treasures of the old world, gold, diamonds, stocks, digital currency, are meaningless. Value has returned to the tangible, the useful, the essential. A well-crafted fishing hook made from salvaged metal is a treasure. A handful of seeds from a hardy mountain plant that can grow in the thin, poor soil is a king's ransom. A sealed, waterproof container, a good knife, a warm blanket, these are the objects of desire. And the most valuable artifacts of all are the relics of the before time, not for their monetary worth, but for the knowledge and connection they represent. A tattered book on agriculture, a laminated map of a drowned state, a simple photograph of a green forest. These items would be treated with a reverence we reserve for the holiest of scriptures. They are windows into the lost world, proof that the paradise of the stories was real. And so we are led to a final, deep reflection on how profoundly we are shaped by the geography that cradles us. Our minds, our cultures, our languages, and our identities are not things we create in a vacuum. They are a conversation with the landscape we inhabit. We are reflections of our home. When that home is so catastrophically broken, humanity itself must become something new. The process is not one of exciting adventure, but of profound and inescapable sorrow. And as these new cultures take root, clinging to their high-altitude homes, they would inevitably be drawn to the greatest mystery of their world, the silent, sunken kingdoms that lie just offshore, in the shallow waters of their new coasts. To survive and to understand who they are, they must become archaeologists of the deep, looking down into the quiet darkness for the answers and the ghosts of the world that made them. What treasures lie buried in the deep? For all of human history, that question has conjured images of sunken galleons, chests of pirate gold, and the lost jewels of forgotten empires. But in the shallow seas of the world after the Great Melt, the treasures that lie waiting in the silent darkness are of a different kind. They are not the spoils of conquest, but the silent, perfectly preserved monuments of our own lost civilization. Let us imagine a small submersible craft, built by the descendants of the survivors, descending into the quiet, green twilight off the coast of the new North American continent. It glides through the drowned and silent streets of what was once the island of Manhattan. The great skyscrapers, once symbols of human ambition reaching for the sky, are now artificial canyons, their glass and steel facades furry with strange new sea growths and encrusted with the shells of unknown creatures. Schools of fish, evolved for this new, brackish world, drift like ghosts through the empty windows of old office buildings. The submersible turns a corner and is met with a sight of profound and heartbreaking beauty. There, half buried in the silt of the Hudson River, is the Statue of Liberty. Her verdigris skin is now the colour of the deep sea itself. Her torch, once a beacon of fire and hope, is dark, but it is not empty. It now provides a home for a colony of pale, bioluminescent anemones that pulse with a cold, gentle, blue-green light. It is a scene of utter tragedy, yet it possesses a serene and haunting grandeur. It is the tombstone of a world. The reason these sunken kingdoms would be so eerily well preserved lies in the chemistry of the deep, still water. The new ocean is largely anoxic, especially at depth. The microorganisms that drive the process of decay, the bacteria and fungi that tirelessly break down organic matter in our world, are overwhelmingly aerobic, meaning they require oxygen to do their work. In the cold, dark, oxygen-starved environment of the drowned cities, the process of decomposition would slow to a virtual standstill. This creates an incredible opportunity for preservation. Things that would normally rot away in a matter of years could persist for centuries, or even millennia. Wooden furniture inside a submerged home, the paper pages of books in a flooded library, the complex polymers of plastics in a landfill, all would be held in a state of suspended animation. The drowned cities of our world would become the most astonishingly detailed and complete archaeological sites imaginable. Unintentional time capsules of our entire civilization. For the survivors living on the high ground, these sunken ruins would become the focus of a new kind of exploration. Their goal would not be gold, but knowledge and survival. They would become archaeologists of the deep, their submersibles, the trowels and brushes of a new age. They would risk the dangers of the depths to retrieve priceless artifacts. Not jewels, but well-made hand tools they could study and replicate. Not art for its own sake, but textbooks of engineering, medicine, and agriculture that could help them rebuild their world. Not weapons, but sealed containers of ancient, uncorrupted seeds. These ruins would be their pyramids, their Library of Alexandria, a sacred and essential link to the knowledge of the ancestors. Taking a much longer view, a perspective of not thousands but millions of years, our lost civilization would leave a mark of a different kind. As the millennia pass, the sunken cities would be slowly buried under accumulating layers of oceanic sediment. The immense pressure from the water and the rock above would compress them, and the unique materials of our world would undergo a slow process of fossilization. The concrete of our foundations, the steel rebar of our buildings, the glass of our windows, and the vast, almost indestructible layers of our plastic waste would be compressed into a single, distinct, and utterly unmistakable stratum in the Earth's geology. To any geologist of the far, far future, whether human or not, this thin layer in the rock would be an astonishing discovery. They would call it a techno-fossil layer, a clear and unambiguous signature of a global, industrial civilization that had, for a brief moment, dominated the planet. Our entire existence, our arts, our sciences, our triumphs and our follies would be reduced to a single, curious line in the planet's stone autobiography. And in this, we find a profound and humbling reflection on the nature of legacy. We build our monuments to be seen, to last, to proclaim our existence to the future. But in this new world, our greatest achievements are rendered invisible. Their stories told only in the crushing dark. Their grandeur witnessed only by the blind creatures of the deep. They are a legacy, written in a language no one can read. A memory held by a world that has forgotten our name. And for the survivors, these physical ruins become the bedrock for something less tangible, but even more enduring. The stories they tell to explain the world that was lost. Every human culture, from the dawn of time, has a flood myth. From the story of Noah in the Abrahamic traditions, to the epic of Gilgamesh in Mesopotamia, from the tale of Manu in ancient India, to Deucalion in Greek mythology, the story of a world washed clean by a divine flood is one of our most ancient and persistent archetypes. But what kind of myth, what kind of story, would be born from a flood that was not a temporary punishment, but a permanent transformation of the world. In the high-altitude villages of the survivors, a new mythology takes root, a story told by every grandparent to every grandchild, a legend that serves as their history, their religion, and their science all in one. Imagine sitting by the weak light of a seal oil lamp, the wind howling outside a small stone hut, as an elder begins the great story. She does not speak of gods in the sky, but of the ancestors, a powerful and brilliant people who lived in the before time, in the low, warm lands that are now forbidden. She speaks of how the ancestors became arrogant, how they learned to drink the sun's fire from the rock in a clear reference to fossil fuels. She tells of how they built towers of glass and steel that scraped the underside of the perpetual clouds, angering the spirit of the world. And so, the story goes, the two great ice giants, the white-haired spirits of the north and the south, were saddened by the ancestors' hubris. They began to weep, and their tears were tears of ice turned to water, a weeping that never stopped, until the world was covered by the great sorrowful ocean, and only the highest mountain peaks, the homes of the humble, were spared. This story, or one of its many variations, would become the central, foundational myth of all future humanity. And in it, we can see the true anthropological function of mythology. A myth is not merely a fanciful tale for entertainment. It is a sophisticated vessel for carrying crucial information across generations in a pre-literate or post-technological society. It is a system for encoding knowledge into a memorable narrative. The Great Melt myth successfully encodes their entire history. A technologically advanced civilization existed before them. It encodes a moral framework. Their hubris and disrespect for the natural world led to their downfall. It encodes practical, environmental knowledge. The source of the water was the ice from the planet's poles. And it provides a cosmology, a story that explains why the world is the way it is, giving meaning and context to their difficult lives. The power of this new myth is amplified because it taps into that deep, pre-existing archetype of the Great Flood. Anthropologists have long speculated that our ancient flood myths are a kind of cultural memory, a distorted echo of the very real and dramatic sea level rise that occurred all over the world as the glaciers of the last ice age melted some 10,000 years ago. For the survivors of the Great Melt, however, the flood is not a distant, symbolic memory. It is their literal, documented, and defining history, the single event from which their entire world was born. This transforms the archetype from a powerful story into the unshakable foundation of their reality. This new reality would also reshape the very tools with which they think, the words they use. Their language would evolve to reflect their new environment. With no deserts, prairies, or vast savannas, the old words for these landscapes would fall into disuse, eventually becoming meaningless, archaic terms in the stories of the before time. In their place, an incredibly rich and nuanced vocabulary would develop to describe their new world. They might have 50 different words for fog, distinguishing between the low-lying sea fog, the high-altitude mountain fog, the drizzling fog, and the thick, toxic fog that sometimes rolled in from the sea. They would develop a complex lexicon for the surface of the water, for the subtle changes in the color of the sky that might predict a storm, for the strange new plants and animals that made up their world. Their very language, and therefore the very structure of their thoughts, would be a product of this new, waterlogged existence. It is a profound reminder that we are, at our very core, storytelling animals. Faced with a catastrophe so vast it defies easy comprehension, we do not simply record the facts. We weave a narrative. We create heroes and villains, gods and monsters, lessons and morals. We create meaning from the chaos. The story of our own lost civilization, the tale of the ancestors who built too high and angered the world, would become the ultimate cautionary tale, a myth whispered by the last embers of humanity to warn them against ever making the same mistake again. And as these generations of people live and die, their lives governed by this great story, the physical planet continues its own, much slower journey. The Earth, having passed through the great fever of the melt, is now settling into a long and quiet convalescence, and in the process, its very voice, the soundscape of the entire globe, is changing. Close your eyes for a moment and simply listen. Listen past the immediate sounds in your room, past the hum of electricity or the distant whisper of traffic. Try to hear the sound of the world itself. Every place on Earth has a unique voice, a sonic fingerprint composed of 1,000 tiny sounds, the whisper of the wind through a particular species of tree, the specific cadence of the local bird song, the distant murmur of a human settlement. This is its soundscape, the auditory story of that place. Now, what story would a world of endless water and perpetual fog tell? What would be the new voice of the planet? Let us listen to it. The first thing we notice is what is missing. The high-frequency buzz and hum of the insect world, the sound that forms the sonic bedrock of any summer evening, is largely gone. The dry, crackling rustle of autumn leaves underfoot has been replaced by the soft, damp squelch of perpetually wet ground. And most profoundly, the anthrophony, the vast and ceaseless symphony of human activity, the drone of airplanes, the roar of highways, the hum of cities, has fallen silent. In its place, new sounds have risen to dominance. The geophony, the voice of the planet's physical forces, is now a constant, low-frequency murmur. It is the sound of the wind, no longer broken by forests and mountains in the same way, but now flowing, almost frictionless, over vast, open stretches of water. It is the sound of the constant, soft patter of drizzle from the low clouds, a sound that never truly ends. And beneath it all, felt more than heard, is the deep, resonant groaning of the Earth's crust as it continues its slow, isostatic rebound, a planetary sigh of stone. The science of this new world of sound is rooted in the concept of acoustic ecology, the study of the relationship between sound, the environment, and the creatures that live within it. The soundscape of any healthy environment is a balanced orchestra, with different species evolving to communicate in different acoustic niches, like instruments playing in different registers. The Great Dying has silenced most of those instruments, leaving the biophony, the voice of life, thin and impoverished. The few creatures that have survived and adapted now call into a much emptier acoustic space. Perhaps the birds that remain have evolved slower, lower-pitched songs to better penetrate the thick, damp air. Perhaps the new amphibians that thrive in the global swamp have developed deep, booming calls that can travel for miles. The entire conversation of life has changed its tone and its content. The physical properties of the new atmosphere also fundamentally alter the nature of sound itself. The thick, perpetual fog is a powerful acoustic filter. The countless microscopic water droplets suspended in the air are incredibly effective at absorbing sound energy, particularly high-frequency sounds. This means that sharp, crisp, high-pitched noises are muffled and muted, unable to travel very far. The world, in essence, has had its treble turned all the way down. The resulting soundscape is bass-heavy, a world of low rumbles and indistinct murmurs. This changes not only what can be heard, but the emotional quality of the world itself, lending a sorrowful and monotonous character to the very air. In listening to this new earth, we are forced to confront the sounds that have been lost forever, a form of sensory extinction. It is the specific, cheerful chirp of a house sparrow. It is the impossibly complex and beautiful song of a humpback whale, now absent from the seas. It is the gentle hum of a honeybee, a sound that was once the very definition of a peaceful summer garden. These are the voices of our old world, and their absence leaves a profound and unfillable void in the planet's acoustic identity. We experience so much of our world, so much of our sense of place and our feeling of safety through our ears. The familiar sounds of home are a kind of lullaby, a subconscious assurance that all is right with the world. In this new era, the planet sings a different song, a strange and melancholy dirge that speaks of loss and profound change. It is a soundscape that would feel alien and unsettling to us, a constant reminder that the world we knew is gone. And as we stand on a high cliff, listening to this new, quiet, and sorrowful voice of the planet, we might look up at the grey, featureless sky and wonder. We might wonder how all of this entire, catastrophic transformation appears from a much greater distance. If we could rise up above the muffling fog and the perpetual clouds and look back at our home from the silent emptiness of space, what would we see? We have all seen the photograph, that iconic, luminous image taken by the astronauts of Apollo 17, the picture we call the blue marble. It is a portrait of our home as it was, a swirling, beautiful sphere of deep blue oceans, white clouds, and the familiar earthy browns and greens of the continents, all hanging like a fragile ornament in the vast, black emptiness. It is an image of peace, of wholeness, of a vibrant and living world. But what would that marble look like now? What would be the new portrait of the Earth, taken from that same dispassionate, cosmic distance? Let us begin that journey, pulling away from the damp, grey surface, rising swiftly through the endless layers of cloud. For a moment, we are in a world of pure, brilliant white, a blinding and featureless expanse. And then, we break through. We emerge into the unfiltered, silent sunlight of space, and we turn to look back. At first, the planet is a deeper, more uniform blue than we remember. The great, white ice caps at the poles, which once acted as the planet's brilliant crown and footstool, are gone. The continents are shrunken, their familiar shapes eaten away by the 66-meter rise in the sea, their green and brown expanses greatly reduced. But as we pull back further, tens of thousands of miles into space, a different feature comes to dominate the view. It is the clouds. The perpetual cloud cover and the continent-sized hyperhurricanes have turned the Earth into a turbulent, brilliantly white sphere, swirled with the motion of its chaotic new atmosphere. It is no longer the calm and gentle blue marble. It is a brighter, shinier, and more violent-looking world, a pale, restive jewel. This new appearance is a direct result of a change in the planet's overall albedo, a measure of its reflectivity. In the old world, the planet had a balanced albedo. The dark, deep blue of the oceans had a very low albedo, meaning it absorbed a great deal of the sun's energy and converted it to heat. The polar ice sheets, in contrast, had a very high albedo, acting as giant mirrors that reflected a significant portion of solar energy back into space, helping to cool the planet. In the first moments of the Great Melt, the instant disappearance of the ice would have caused the planet's total albedo to plummet. The Earth would have become a much darker, much less reflective object, absorbing a catastrophic amount of additional solar energy. But this phase would have been fleeting, immediately followed by a much more powerful and lasting change. The formation of the permanent, global cloud layer would have the opposite effect. Clouds, being brilliant white, have an extremely high albedo. This new, planetary shield of clouds would act as an astonishingly effective mirror, reflecting the majority of the sun's light and energy back into space before it ever had a chance to reach the dark, absorbent oceans below. From a great distance, therefore, our planet would appear significantly brighter than it did before. It would be a pale, white marble, shimmering in the light of the sun. This change would be obvious to any civilization capable of observing our solar system from afar. The primary way that we, in our own time, study planets orbiting other stars' exoplanets is by carefully analyzing the faint light that reflects off them. From this light, we can determine a planet's size, its approximate color, and its albedo, which allows us to make educated guesses about its composition and climate. To a distant, alien astronomer, the Earth after the Great Melt would present a confusing puzzle. They would see a planet of the right size, orbiting its star within the so-called habitable zone, where liquid water could theoretically exist. Yet, its extremely high albedo would be more consistent with a planet like Venus, one with a thick, planet-shrouding, and likely toxic atmosphere. They might classify Earth as a water world with a runaway greenhouse-induced cloud deck, a turbulent and inhospitable place, and they would likely conclude that the chances of it harboring complex surface life were very, very low. They would see the evidence of the fever, but they would be blind to the struggling life hidden beneath the beautiful, white blanket of clouds. And in this cosmic perspective, we find a final, profound reflection. From the serene, silent vantage point of space, our entire catastrophe, the drowning of our cities, the extinction of countless species, the sorrow and the struggle of the survivors is rendered completely invisible. It is subsumed into a new and strangely beautiful aesthetic. The great drama of our world becomes just a silent, shimmering dance of light and shadow on a pale, distant sphere. A quiet reminder that in the grand, impartial gaze of the cosmos, the end of a world is a tragedy only to those who lived on it. And yet, this shimmering, white state is not an ending. The planet, in its new, bright clothes, is not dead, but is merely in a different phase, and over a timescale that makes human history seem like the blink of an eye. The Earth's own deep, slow, and patient mechanisms of healing and rebalancing will begin their work. Every action, in the grand and patient world of physics, has an equal and opposite reaction. For every force, there is a counterforce. For every peak, a valley. For every great warming, a long and profound cooling. And so we must ask, what is the equal and opposite reaction to a great, world-covering, instantaneous melt? The answer, written in the slow, deliberate language of geology and chemistry, is an equally great and equally world-covering new ice age. This is the long recovery, the planet's slow and deep exhalation after the fever has broken. Let us step away from the human scale of time, the fleeting scale of days and years and even centuries, and watch the Earth over a span of millennia. From a detached vantage point, we watch as the new, chaotic world begins to find a kind of peace. The hyperhurricanes, their fury slowly tamed by the gradual rebalancing of the planet's temperatures, begin to soften into mere global-scale storms. The violent earthquakes and volcanic eruptions of the Great Rebound lessen in their frequency and intensity as the continents settle into their new, lighter positions. And on the high plateaus of the Andes, the Himalayas, and the newly risen lands of Antarctica and Greenland, a subtle but momentous change begins. The perpetual drizzling rain begins, more and more often, to fall as snow. At first, it melts away each spring in the weak, diffuse sunlight that filters through the clouds. But then, after a few thousand years of slow, atmospheric healing, a summer arrives that is just a little bit cooler than the last. And on the highest, coldest peaks, a patch of last year's snow survives. The next year, more snow falls on top of it, and it too survives the summer. Slowly, almost imperceptibly, the process that built the great ice sheets of the old world begins anew. New glaciers are born. This slow refreezing of the world is driven by one of the planet's most powerful and patient self-regulating mechanisms, the carbon cycle, specifically a process known as silicate weathering. In a strange irony, the very storms that ravaged the New World now become its primary tool of healing. As rain falls through the atmosphere, it dissolves a small amount of carbon dioxide, or CO2, forming a very weak carbonic acid. In our New World, the rainfall is constant, and the air is still rich with CO2 from the decay of the drowned biosphere. This incredibly diluted acid rain falls upon the vast, newly exposed landscapes of raw, pulverized rock. The land scoured clean by the old glaciers and lifted up by isostatic rebound. This rock is rich in silicate minerals. The carbonic acid in the rain reacts with these minerals, breaking them down in a slow chemical conversation. The crucial outcome of this reaction is that the carbon dioxide from the atmosphere becomes locked up into new carbonate minerals. The constant rains wash these new, stable minerals down into the rivers and out into the ocean, where they eventually settle on the seafloor, becoming part of the geological sediment. The carbon has been sequestered. It is a process of planetary scale scrubbing of the atmosphere, a thermostat that works on a timescale of hundreds of thousands of years. It is slow, but it is relentless, and it is inevitably, powerfully, pushing the planet towards a cooler state. And as this slow cooling continues, another, more ancient rhythm begins to reassert its influence. The Milankovitch cycles. These are the gentle, cosmic pacemakers of the Earth's ice ages. They are the subtle, cyclical changes in the Earth's orbit around the Sun, the tilt of its axis, and the wobble of its spin. These cycles, unfolding over tens of thousands of years, slightly alter the amount of solar radiation that reaches the planet's northern latitudes, making the summers warmer or cooler. In the old world, these cycles were the gentle nudge that would either push the planet into an ice age or pull it out of one. Now, with the planet already in a pre-chilled state, its atmosphere being slowly scrubbed of CO2 and its surface kept cool by the bright, reflective shield of clouds, it is exquisitely sensitive to the next cool phase of the Milankovitch cycle. When that cosmic summer arrives, the one that is just a little more distant, a little less direct, it is the final push the climate needs. The summer snows no longer melt at all, even in the lower latitudes. The small, new mountain glaciers begin to merge, forming regional ice caps. These ice caps, being brilliant white, have a very high albedo, reflecting even more sunlight back into space and actively cooling the region around them, which allows them to grow even faster. A feedback loop is initiated, and the long recovery tips over into a full-blown glaciation. And in this, we find a profound reflection on time and scale. Our great catastrophe, the instantaneous melt that we saw as the end of everything, is revealed from this deep perspective to be just a brief, violent spasm in the planet's much longer, much slower life. It was a single, discordant note in a symphony that plays over eons. The planet has a deep, quiet wisdom, a rhythm of healing that is far more powerful than our capacity for destruction. And as the new ice begins its slow, silent, and inexorable advance, covering the world once more in a blanket of white, a new generation of life, born from the handful of hardy survivors of the Great Dying, begins to spread and adapt to a world that is once again being claimed by the cold. Who inherits the earth when the old world is gone? When the great cities are silent tombs in the deep and the dominant species has faded into a geological memory? Who is left to walk the new, strange lands and swim in the new, cold seas? Life, we must remember, is a stubborn and creative force. A mass extinction, as devastating as it is also a clearing of the stage. It is an emptying of the house, leaving countless rooms and roles available for new actors to fill. And so, in the millions of years that follow the great melt and the beginning of the new glaciation, the Earth witnesses a quiet and wondrous explosion of new life. Let us take one final journey, a speculative safari into the world a million years from now. The air is clean and crisp, the light a brilliant white, reflected from the vast ice sheets that now cover much of the northern and southern hemispheres. In the vast, marshy wetlands that border the equatorial oceans, we see herds of creatures that look something like giant capybaras, descendants of the few rodent species that survived. They are hunted not by cats, but by a new predator, a 6-foot-tall, flightless bird, a descendant of a hardy species of rail, which has evolved a powerful beak and strong legs to become the apex predator of this new continent. In the seas, which have slowly regained their salinity and their oxygen, we do not see whales or dolphins. Instead, the niche of the intelligent, social marine predator has been filled by a creature that has been waiting in the wings for 300 million years. The octopus. We see them, perhaps, hunting in cooperative packs, their astonishing intellect now directed towards complex new strategies, their skin flashing with a language of colour and light that we can only guess at. This explosion of new and diverse forms from a few ancestral stocks is a process known to evolutionary biologists as adaptive radiation. It is life's standard response to the opportunity of a wide-open ecological landscape. After the dinosaurs were wiped out 66 million years ago, the mammals, which had been small, nocturnal creatures for 100 million years, suddenly found a world free of giant reptilian predators. They underwent a spectacular adaptive radiation, diversifying into the vast array of forms we know today, from bats in the air, to whales in the sea, to us. In our new world, the same process unfolds, but with a different cast of survivors. Perhaps the only surviving large mammals were hardy mountain goats, whose descendants radiate out to become the new grazers, the new diggers, the new climbers of this future Earth. Perhaps the survivors were raccoons, whose intelligence and adaptable paws make them the perfect candidates to become the new primates. Life, given empty niches, will always rush to fill them, exploring 1,000 new and beautiful forms. As we watch this new world unfold, we would also notice familiar shapes and strategies emerging from unfamiliar lineages, a principle known as convergent evolution. This is the tendency of different species to independently evolve similar traits when they live in similar environments or have to solve similar problems. The wings of a bat, a bird, and an insect are a perfect example, three different evolutionary paths that all arrived at the same solution for flight. In our future world, we might see a descendant of an otter evolve, a sleek, fish-like body with a powerful tail and fins, becoming almost indistinguishable from the dolphins of the old world. We might see a species of burrowing lizard evolve into a form that mimics the moles we once knew. The roles in the great play of life are often constant. It is only the actors who change. And what of the most complex role of all? What of intelligence? Is a human-like technological consciousness an inevitable pinnacle of evolution? Or was it a magnificent, and perhaps tragic, fluke? This is the great, open question. If a new species were to achieve self-awareness in this distant future, how would they see the world? As they developed their own geology, they would inevitably discover the strange, thin, and unnatural layer of plastic, concrete, and refined metals that our civilization left behind. How would they interpret this technofossil layer? Would they see us as gods, a mythical race of creators from a golden age? Would they see us as demons, a warning of the dangers of a certain kind of intelligence? Or would they simply see us as a strange, short-lived biological phenomenon, a species that briefly flared and then consumed itself, a curious dead end on the great, branching tree of life? In this final, wondrous vision of a world reborn, we find a deep and peaceful reflection. We often think of our world, our time, our ecosystem, as the definitive, final version of life on Earth. But it is not. It was just one chapter in a much, much longer book. The end of our world is not the end of the world. Life is a current that cannot be stopped. It can be dammed, diverted, and diminished, but it will always find a new path forward. And as we look back on this entire epic cycle, from the shattering of the ancient ice to the birth of these new and wonderful creatures, we are left with a final, lingering question. What is the feeling, the lesson, the quiet wisdom that remains at the very end of this long journey? We think of mountains as symbols of permanence, and of rivers as symbols of constant change. We say that something is written in stone to mean that it is eternal. But on the deep, geologic timescale of the Earth, this is not true. The mountains are fleeting, rising and falling like slow-motion waves over millions of years, while the water, the river, is the truly permanent thing, tirelessly working to wear the mountains down to the sea. And so we must ask, was the ice, which seemed so solid and so eternal, the mountain or the river? Let us watch our entire story again, but this time from the perspective of deep time, a perspective where a million years passes like a single day. We watch as the great white ice sheets of the old world breathe, growing and shrinking with the patient rhythm of the orbital cycles. Then, in a brilliant blue-white flash, a single, violent moment on this immense timeline, the ice is gone. The oceans rise in a single, swift inhalation, and the continents, those things we thought were so solid, visibly rebound, breathing a slow sigh of relief. The planet's atmosphere swirls into a chaotic, angry vortex of white cloud, and for a long, turbulent age, the world is a feverish, unsettled thing. But then, just as slowly, we watch the fever break. We see the great, slow scrubbing of the air, the gradual calming of the storms, and the first, tentative return of white to the tops of the new mountains. The white spreads, slowly, patiently, like a frost on a window pane, until the ice has returned, and the planet is once again breathing in the slow, deep rhythm of a glacial age. It is a planetary breath, a single, complete cycle of crisis and recovery. To truly grasp this perspective, we can use an analogy to compress the Earth's 4.5 billion year history into a single, understandable year. In this cosmic calendar, the very first, most primitive life appears sometime in late March. The dinosaurs would emerge in the middle of December and would dominate the world for 2 weeks, vanishing in a cataclysm on the evening of December 26th. The entire history of our species, Homo sapiens, would begin in the final hour of New Year's Eve, at about 11:52 p.m. All of our recorded history, all the pyramids, all the empires, all the art, all the science would take place in the last 10 seconds before midnight. Our instantaneous great melt, the entire world-altering story we have just witnessed, would be a fraction of that final second, a blinding flash of light just before the clock strikes 12. This perspective does not diminish the tragedy of the event, but it reframes it. It was not the end of the world's story, it was merely the violent turning of a page, a dramatic, fiery end to one chapter, and the quiet beginning of the next. This leads us to a gentle, philosophical question, a thought experiment known as the ship of Theseus. The question is this: if you have a wooden ship, and over the years you replace every single plank of wood, every sail, every rope, until none of the original material remains, is it still the ship of Theseus? Our Earth, after the melt, is this ship. Its coastlines have been replaced. Its climate has been replaced. Its atmosphere has been replaced. Its species, its very cloak of life, have been replaced. Is it still the same Earth? There is no correct answer, but the question itself holds the wisdom. It teaches us that identity, for a planet as for a person, may not reside in static, unchanging material, but in the continuity of the form, the persistence of the pattern, the unbroken flow of the story. And perhaps, in this, there is a kind of peace to be found, a gentle philosophy of acceptance. Our journey has been one of great and terrible change, but change is the fundamental, and perhaps the only, constant in the universe. The Stoic philosophers of ancient Rome taught the wisdom of understanding what is within our control and what is not, and of accepting the great, flowing river of time and fate. The ice was never truly permanent. It was just water, pausing for 100,000 years on its long, cyclical journey from the sea to the sky and back to the sea again. Our civilization, too, with all its works and wonders, was just a pause, a fleeting, beautiful, and complex arrangement of atoms that came together for a short time and then dispersed back into the great cosmic flow. The true nature of the universe is not the solid state of the ice, but the flowing, adaptable, and persistent nature of the water. The memory of the ice is not a memory of something lost, but a memory of one of the infinite, beautiful forms that water, and life, and worlds can take, if only for a little while. And so, as our long journey of the imagination comes to its close, and we let the great river of time carry us forward, we are left with one final, quiet sound, a gentle lullaby from a world that has, after all the fire and the flood, finally found its peace. After all the roaring of the storms, and the groaning of the rising land, and the remaking of the entire world, what is the final sound? After the great silence of extinction, and the quiet whispers of the new myths, what is the sound that endures? It is a gentle and simple sound. It is the steady, quiet hum of a planet that is, once again, simply alive. It is a sound composed of 1,000 new and peaceful details. It is the slow, grinding creep of a new glacier inching its way down a mountain valley, the sound of geology happening in its own patient time. It is the soft dripping of meltwater in a vast, sun-dappled forest of strange new trees, a sound that promises continuity. It is the gentle lapping of the waves of a cool, clean ocean on a sandy shore that has never known a human footstep, a sound of peaceful, eternal rhythm. The earth, in its new form, has found its new voice, and it is a voice of deep, resonant, and abiding calm. What we have witnessed throughout this long and winding story is a profound demonstration of homeostasis, the tendency of a complex system to maintain a stable, internal equilibrium. We can think of the planet, in a metaphorical sense, as a single, living organism. The Great Melt was a trauma, a shock to the system, a raging fever that threw every one of its vital signs into chaos. But the deep, interconnected systems of the Earth, its geology, its chemistry, its atmosphere, and its life, all began the slow, unconscious work of healing. The carbon cycle acted like the planet's respiratory system, slowly breathing the excess greenhouse gases out of the atmosphere. The water cycle, through the clouds and rain, acted like a circulatory system, redistributing energy and washing the air clean. And life itself, in its stubborn resilience, acted as the agent of renewal, finding new ways to thrive and, in doing so, building a new, stable biosphere. The planet's body, after a long and difficult convalescence, has healed itself. It has returned not to its old state, but to a new and different state of health. This healing reveals the most fundamental truth of our universe, the nature of cycles. Everything we have seen is a part of a wheel, one of the countless nested wheels that turn the cosmos. We saw the water cycle in its most dramatic form, moving from solid ice to liquid ocean to gaseous cloud and back to solid ice again. We saw the carbon cycle, moving the element of life from the air to the rocks to the sea and back again. We saw the great, slow cycle of the rocks themselves, rising and falling, being weathered and reformed. We saw the cycle of life, of mass extinction, clearing the way for the explosive radiation of new species. And all of this is nested within the grandest cycles of all, the slow, celestial waltz of the planets around the sun, and the great, patient cycle of the stars themselves, being born from dust and returning to dust. Our story, in all its epic scope, was just one turn of one of these infinite, beautiful, and eternal wheels. And so, we arrive at the end of our journey. We have imagined the end of a world, and in doing so, we have perhaps learned something about the value of our own. The story of the Great Melt is, on the surface, a tragedy, but it is also a profound story of resilience, a testament to the deep, quiet, and unstoppable power of life and time. It is a story that teaches us that even after the loudest and most final of endings, there can be the quietest and most beautiful new beginnings. And perhaps the final wisdom is this: the breathtaking beauty of our own world, the world of the blue marble, is not rooted in its permanence, but in its precious, fleeting fragility. The knowledge that it can all change, that it is all part of a great, flowing, and impermanent river, is what makes this single, shining moment, our moment, so infinitely valuable. Thank you for joining me on this long, quiet journey tonight. I hope it has brought you some sense of wonder and some measure of peace. May you rest now, and may your dreams be filled with the quiet, resilient, and breathtaking beauty of our own precious and wonderful world. If you have found a moment of calm here, please do consider liking this video and subscribing for more soothing stories from the quiet corners of science. Until next time, sleep well.